9 out of 10 people hate this developer, the one that doesn't automate anything. And if you're watching this, the likelihood is that you're that developer. So how can you automate your deployment so that you never have to deal with another deployment error ever again? CI/CD, or continuous integration and continuous delivery, is the practice of automating the manual tasks that us mere mortals usually have to do when we're deploying our code to production. Things like compiling our code, or running tests, or uploading our code to our cloud infrastructure. Automating things not only helps to save a lot of time, it also removes the possibility of human error causing your entire system to burn to the ground. There are a bunch of tools out there that can help you get started with CI/CD, and I've used a few of them. All of them are great at what they do. However, in this video, we're going to be focusing specifically on GitHub Actions. Let's get started. Ultimately, all you need to get started is a GitHub repository. If you don't have one, I'm going to leave a link in the description below to the one I'm using for this video. At the top of your repository page, you should see the Actions tab. Once you have some automations running on your repository, this is where you can keep track of the logs for each workflow. Every time they are run. When it's running, we can see the progress of each step in the GitHub Actions workflow. So if the workflow fails during some tests, we know that the code is broken and therefore we don't want to deploy it to our server. If the workflow is successful, we're going to see a big green check mark telling us that everything is working within our code base. One of the great things that developers really like about GitHub Actions is that it comes with a bunch of different templates that you can use to easily run specific actions. However, for this video, we're going to create our own from scratch. To do this, you can create a new YAML file inside of the GitHub Workflows directory of your project. We're going to give our workflow a name and create our trigger, which is going to tell GitHub Actions when we want to run our workflow. You can run workflows using a variety of triggers. For example, every time we push code to our main branch, we might want to deploy it to our production server automatically so that we don't have to do it ourselves. Or every time we create a new pull request, we might want to test the code to make sure that everything is working before we merge that code into our main branch. These are actually the two examples that we're going to build today. There's a huge list of different triggers that you can use within GitHub Actions. So if you want to find out more about them, I'd recommend visiting this page on the GitHub documentation. Anyway, because this workflow is going to be used to test our code, we're going to run it every time a pull request to the main branch is created. So let's say I've got this really cool feature that I want to merge into my main branch. I'd create a pull request, which would trigger this workflow. Next, we can create a list of jobs that we want to include in our workflow. We're going to call our job test, and then we're going to define the operating system that we want the job to run on. There are other options that you can use, but realistically, Ubuntu is the most common one that people will use within GitHub Actions. And we're going to use a Node.js container because in this example, we're using Node.js for our project. That will automatically install Node.js for us so that we don't have to do it manually through the command line using Ubuntu. It just saves a bit of time. The first step is going to be adding our code to our virtual environment using the checkout action. Now I want you to have a think about the steps that you would take if you were testing your code manually. Firstly, you want to make sure that all of your dependencies have been installed for your project. We can do this by running npm CI, which is going to run a clean install. Once your dependencies have been installed, you can run your tests using whatever library you're using in your project. I tend to use Jest when I'm working with a JavaScript project. And then finally, I'm going to run the build script, which is going to compile our project. We can commit this code over to our repository, and then I'm going to create an example pull request for this really cool feature that I've just built. As you can see, the GitHub Actions workflow is going to spin up a virtual environment, run our tests, and then confirm that our code is working as expected. So automatically I know the code is working without having to pull the pull request onto my local machine and then running the test manually. Now that we know that our code is going to be working when we merge it into the main branch, we want to figure out how we can use GitHub Actions to automatically deploy our code to our production infrastructure. This is the continuous delivery or CD part of the process. If we weren't automating anything, your deployment process may look a little like this. First, I'm going to run git pull to get the latest version of my code from my repository. Then I'm going to run git checkout to make sure that I'm in my main branch, run npm install, npm run build, and then deploy my code to the server using this long command, which I might get wrong. Oh, and then SSH into the server to install the dependencies and restart the Node.js process. Okay, as you can see, this took a long time and it was pretty complicated for such a small project. So let's automate this. We're going to create another YAML file inside of our GitHub Workflows directory, which is going to be triggered every time some code gets pushed to our main branch. Inside of this workflow, we're going to run a job which is going to build our project and then deploy it to our server. Like we did with our testing workflow, we're going to run our job on Ubuntu, check out the code, and install Node.js. We're going to run npm CI to do a clean install of the project's dependencies and then run the build script. Once the build is completed, we're going to deploy our code using SCP, which is going to upload all of our files to the server. Because access to our server is protected using SSH keys, we need to take an SSH key that has access to our server and add the content of it to our GitHub Actions secrets. This is where you can store sensitive credentials that need to be used within your GitHub Actions, but can't be stored within your repository for security reasons. For example, your Stripe or OpenAI keys. You wouldn't want to put them in your repository. I've also added the address of the server that we're going to be deploying our code to, as well as the username that I have on the server. We can then access our secrets within our GitHub Actions workflow and add our SSH key to our virtual environment. Now we can upload our files to our server using SCP in the exact same way that we would have done it using the command line. The final step in our deployment process is to SSH into the server, install the dependencies, and then restart the Node.js process. In this case, I'm using PM2 to manage the Node.js process. You can test your workflow using act, which allows you to run GitHub Actions scripts offline. To do this, you'll need to have Docker running on your local machine, as well as create a .secrets file within your project directory. That secrets file is then going to be used to replace what would be GitHub Actions secrets. So make sure you don't actually put your deployment secrets in that file. You need to put some test ones in that you're maybe deploying to different infrastructure, because you wouldn't want to run a test on actual production infrastructure. You can then run the act command to test your workflow and make sure that everything is working correctly. Once you're happy with your workflow, you can publish it to your GitHub repository. Now, if we merge that super cool feature that we were testing earlier, you can see that we've triggered this automated workflow, which is going to deploy our code to our production server. So now you can say that you understand CI/CD. If you learned something in today's video, please leave a like down below.
Hey team, Sid here with DevOps Directive, and we were able to download that dependency from our cache rather than needing to pull it from NPM directly. So that's a Node example. On the left, you can see the documentation for how this would look with Go, and each language is going to be slightly different in terms of where it stores its dependency. These work at the path services Go API Golang, and then build, push,
So in this video, I'm going to go.
Hello everyone, in this video we are going to be making a deployment pipeline on AWS using AWS Code Pipeline.
Let's learn what CI/CD is, but more interestingly, why these concepts are. Let's learn what CI/CD is, but more interestingly, why these concepts are so important and what problems they solve using real-world scenarios from actual engineering projects. If you want to have a simple but actionable CI/CD checklist, you can grab one below that we created specifically for this video. So let's get to it. Imagine you and your team are developing an application. The first version is done, so now it's time to deploy the app on a server. You check in your code and try to merge it into the main branch. You get merge conflicts because other engineers in your team also made some code changes before you. So you fix those issues manually, you try to merge again. Now a simple Jenkins job runs tests on the main and discovers a bunch of issues. Well, now we rush to fix them because we just broke the main branch. So we fix those issues, and after all these fixes and code changes from different developers all in the main branch. Now it's end of sprint. So we want to deploy all our changes because we need to release them at some point, right? So we do a code freeze, which means no one's allowed to merge anything to main until we deploy the current state with all those changes. So you and your team start testing the latest state of the main branch to make sure that new features all work properly, but also make sure that we didn't break any previous features and functionality. So we do this intense testing manually before we deploy. Again, we find some issues, so we jump on it to fix it immediately because the clock is ticking on deployment. Once all the issues are resolved and the main branch is tested to the best of our ability, it's the deploy time. So we'll take a deep breath to prepare mentally. Someone on the team checks out the main branch locally. They pump the release version maybe and push that to Git. And let's say we have a simple Jenkins build that we scrambled together that runs some tests, builds a Docker image, and pushes to the Docker repository. Oh, the build is over. Now let's manually modify a Docker Compose file or Kubernetes manifest file, or maybe we edit a new service. So let's add that Kubernetes YAML file manually as well. And now again, someone who is knowledgeable and senior in our team, they connect to Kubernetes cluster with kubectl command and apply the new manifest files. Or if the app is running on a simple server, they SSH into the server, they stop the containers and restart them with a modified Docker Compose file. And then they give testers the URL and say, hey guys, just deployed a new version. You can test now. Let me know when you're done so I can manually prepare the deployment for prod environment, which will be the same process, but this time with more shivering and anxiety because we are going live now, and deploying to prod, we need to be prepared for some surprises. And let's not do that prod deployment on a Friday evening or any evening really, because if something happens and users cannot access the app and no one's there to fix it overnight, that will be pretty bad. So as you see, we have tons of constraints here at every stage because of one common element, which is human. Because human deployment and monitoring system is always time constrained and much more error prone. Now, if you're an engineer who has been implementing CI/CD, you will probably cringe at this story, but it is and has been a reality in many projects. So how do we take this manual mess of a workflow, fully constrained by human in the loop, to a beautifully streamlined CI/CD pipeline that would be a dream of every developer team? Great question. Let's take this project and optimize it step by step to understand every element of CI/CD. Let's start from the very beginning, at the very left of the workflow. First, how do we cure the problem of a bunch of issues and failed tests every time we merge our feature branch into the main? Well, wouldn't it be more efficient if we ran those tests in the feature branch itself before trying to merge it? Like, why are we waiting for it to be merged? to test if it breaks anything. Plus, if we have multiple branches, let's test each one individually before we merge them back into the main. Because when 3 different features are merged at the same time with large code changes, we won't even know which combination pieces had issues. Maybe one feature affects the other in some way, so untangling the issue may be more difficult. So we run those tests on individual branches to find any bugs right before we merge. So developers working on those branches can fix their own code. But wait, this can be done better. Why are we waiting right before merge to run those tests? Let's run them on every commit to the branch, so it's easy to isolate the issue. Some developers program the entire thing locally first for like days, and then push the whole implementation at once to the remote. So instead, we encourage our developers to commit and push to remote more often, so their smaller changes are tested more frequently. And if there are any issues, they can fix those before making even more changes. So we are committing smaller code changes more frequently, and we test them right away. And that, my fellow engineers, is called continuous integration, CI. So we are integrating our code changes often in small sizes into the main branch. Let's look at the impact we just made. We are catching the issues faster and earlier in the development workflow, and instead of complex entangled issues that testers would find later, we have simpler isolated issues, which means developers can fix those right away, even while working on their current feature, so the whole stress is not piling up at the end right before release. Plus, developers aren't frustrated because other developers in the team commit code changes that mess up their functionality. No entangled merge conflicts. Looks pretty good already. Speaking of catching issues early and making code reviews more efficient, this is where our sponsor CodeRabbit comes in. You know how frustrating it is when your pipeline fails and you have to is that CodeRabbit is off developers locally checking out the code to build Docker image and then SSA message into the server or connect to